Recording. Okay. All right. Welcome everyone to our webinar for the NASA Overflight of Toledo. And as I mentioned before, we have a little technical difficulty in that Dorothy Hall, who's our main speaker today, she's at NASA Goddard. And NASA Goddard is blocking the Zoom signal. So she can't call in through Zoom. She's trying to call in through the phone number that we just got. So we'll see if she can call in. Until then, I will do the talking for a little bit. Share my screen. PowerPoint. That's good. All right, so I'm Dr. C. Everybody knows me, I think. I should. And this is part of a project called Mission Earth. And the partners are on this diagram. So it's University of Toledo, Boston University, Wested, Tennessee State, University of California, Berkeley, and NASA. Okay, so I'll introduce Dorothy more later. We'll talk about the ice a little bit more later. So what we're doing is we're looking at the urban heat island effect. And as you can see here, not all surfaces absorb and also emit and or reflect energy the same way. So asphalt, being dark, can absorb lots of energy and then warms up. Grass, for instance, it absorbs the energy, but then it gives it off easily because it has a lot of surface area. So we tend to get warmer areas in the cities and cooler in the countryside. Here's a MODIS image. And this MODIS image shows blue being cooler and red being warmer. You can see that the Great Lake Erie is blue, that's cool. This was the April 15th image, tax day. Woohoo, tax day, great. But anyway, you see the red here, near Lake St. Clair, that's actually Detroit. I'm gonna check what the chat says. We don't have audio. Oh, I'm sorry. So Diane, audio, but nothing I can do about that. Does everybody else hear me? She has that. Does everybody else hear me? Nobody's answering yes or no. I see Janet smiled. So Janet, do you hear me?
I hear you.
Okay.
Hey, you just got Dorothy online too.
I see Dorothy there, yes. So if you hear me, I can hear you fine, good. That's Brian.
Okay.
All right, so Dorothy, you say something and we'll see if we can hear you.
Kevin,
Yes.
I just was able to connect just now.
Good. Hi.
Hi.
So welcome.
Thanks. I missed everything until just this minute.
Well, it's more or less us talking about calling you or having you.
Oh, I'm sorry about that. I don't know what the problem was, but I kept trying and finally it worked.
Oh, okay, great. Well, there you go. All right, so just, I don't know, I was wondering if we should have a little introduction of the schools that are involved here to say hi. I'm not sure if that's too crazy or not, but here's my students from the University of Toledo.
Hi.
Everybody.
Hi.
So we have Ricky Becker from the University of Toledo as well.
Hi, everybody.
The professor just sitting by himself.
Hiding in my office, yep.
We have Steve France's group from Roswell Kent Middle School in Akron. We're waving.
Hi.
Hi.
There you go. Good job. Okay, so we have Diana Johns from Crestwood High School. That's in Dearborn. So waving there. See you guys. Hi. Yeah, they got.
Hi.
Sean Pollock from Monroe Middle School. Zooming around.
I don't see you, but
She's. Right, we have the desk. All right, hi, Sean. Hi, kids. We have John Moore calling in from, actually from New Jersey, the Palmyra Cove Nature Discovery Center.
Ah,
Let's see, we have a student. It's Brian Ellis from the Natural Science Technology Center. He says he has 25 students watching and listening.
wow.
Marcy Burns from Norwalk. Oh, but by the way, the Natural Science Technology Center is a school in Toledo, and the plane should go pretty close to their school. Marcy Burns and her class from Norwalk School. Giving us a
Hi.
panoramic. Myself again. Diane LaPlante, she may not be able to hear us. Oh wait, yeah, she has audio now, she says. Okay, good. So Diane LaPlante from Burndale Elementary School here in Toledo. Okay, oh, Penny Choma from McTighe Elementary School is watching. The plane's supposed to go right over McTighe, by the way. I don't know who NCLIC is. 50 students. Oh yeah, that's at the Natural Technology Center again. April Ames is a professor, some kind of professor, right, April? At the University of Toledo. Public health. Yeah. All right, so let's start it off here. I'll introduce Dorothy. Dorothy, am I showing your slides for you?
No, well, I can try to
Okay, great.
bring them up right now. Can you see them?
Not yet, but I'm gonna share my screen first. I just have.
Maybe.
So if you guys can see, this is Dorothy Hall, Senior Scientist in Cryospheric Sciences from NASA Goddard Space Flight Center. She's also at Michigan State part of the time. I'm not sure how all that works, but she's very accomplished in her research with 130 publications, at least one book on remote sensing of snow and ice, 20 book chapters, and it said online that you're a fan of Frozen. I couldn't actually find out where you graduated with your PhD. So.
Well, thank you, Kevin. Let's see. If you want me to get started, I see now how to share the screen.
Great, why don't you go ahead?
And it's funny, I don't know where that fan of Frozen thing came from, but it did get there somehow. Okay, can you see my screen now?
Yes.
Okay, let me bring up the presentation. Okay, now, is that good?
Yes.
Okay, great, great. Okay, so what I'm gonna do is talk for just about 10 minutes about a major snow experiment that NASA is currently conducting in Colorado and also over Michigan, over the Great Lakes, and over Toledo at the end of this month. And what that is called, it's called SnowEx. It's a NASA Airborne snow experiment, which we hope will lead to a snow satellite mission. And the part that we're most concerned about, which I'll get to later, is called GLAWEX, and I'll explain that. And that's the transit flight that we're all going to be involved in. But just to give you a little bit of background on SnowEx, it's a major program for NASA, run out of NASA headquarters. This just gives you some of the names of the people involved and a picture from the field that was just taken a couple of days ago in Colorado. So why do we want to study snow? In fact, why does NASA want to study snow? There are lots of reasons. Snow cover has a major impact on the US economy, particularly water resources. In fact, not just the US economy, but the global economy. Over 1 billion people, about 1/6 of the global population, maybe 1.2 or 1.3 billion people, use water from snowmelt for their water resources, for either drinking water or irrigation or for hydropower and other reasons. Also, snow cover is a major hazard, or can be, as you know, for many areas of the country, of the world. And it's a major driver of weather, and also it influences weather and climate. In terms of ecology, snowmelt is very important because it provides a pulse of water at the beginning of the growing season to help crops get started. It controls the energy balance of the area, because what that means is that if you have a covering of snow, it reflects a large amount of the solar radiation right back to space, instead of having that absorbed in the surface of the earth. So that affects the surface temperature of the earth, or at least in a particular region. Also, if you have early snowmelt, which we've had recently, particularly in North America, parts of North America, and even the Western US, this can cause a dangerous lengthening of the wildfire season. So some of the major questions that we're asking with the SnowEx mission, how much water is stored in the Earth's terrestrial snow cover regions? Well, we can look at satellite data and say, oh, I know where the snow is. And in fact, we've been able to do this for 50 years from satellites at varying resolutions. Starting in 1966, NOAA began mapping the location of snow cover. And so we have this long record of snow cover in the Northern Hemisphere, and we can see changes in snow cover over time. But one thing we have not been able to do from space is determine the distribution of snow water equivalent. And we don't even know which are the best sensors for doing that. We can measure snow water equivalent, and what that means is how much water is in the snow. Not just where is it, but how deep it is, how dense it is. And so if you melted it, how much water would you get for those water resources that I was talking about earlier? We can do that from space for very specific locations, but we can't do that globally. And that's what SnowEx is all about, to try to figure out which are the best sensors that we can use to measure snow water equivalent on the global scale. So some of the other questions that we're trying to answer, as I just said, we're looking for the optimum combination of sensors. So in Colorado right now, during the field experiment that's going on, we've got a number of aircraft flying over with different sensors that are looking at the snowpack in different ways. So we're trying to figure out how to combine those measurements from those sensors to measure snow water equivalent, both in areas that are devoid of vegetation and in forested areas where we have to see through a lot of trees and a lot of dense vegetation to get to the snowpack. We want to see how the sensors work under those conditions. So this is where, if you see the map in the lower left, actually maybe I can even show it. Yeah, here on here's where the cursor is. This is where there's a team of about 50 scientists on the ground measuring snow cover there in Colorado. While I have this map up, I'll show where we will go. The plane will fly at the end of this month from Colorado over Lake Michigan, over the state of Michigan, into Toledo to get our flight lines in over the Great Lakes, over Michigan, and over Toledo. I'll get into that in a minute. But right now, all the airplanes and people are on the ground in Colorado making these measurements. And these are just some views from the area. They did these snow pits to characterize the snowpack. This is an instrument that was intentionally left there. It's a radar to measure the snow for the entire snow cover season. This on the right is an automatic weather station that was put up in the fall and will stay for the entire winter. Okay, now I'm getting into the part that we're almost concerned about, and that we call GLAWEX, Great Lakes Winter Experiment 2017. There have been a few GLAWEX experiments before this. We're completely different, but we decided to use the same acronym. We're going to have 3 flight lines, as I mentioned. over Lake Michigan, over Michigan, a snow flight line over Michigan, and then flying over Toledo on the way of the P-3 aircraft on its way back to Patuxent Naval Air Base in Maryland. The objectives of this GLAWEX mission are to improve the ice type and ice classification algorithms or ways that they measure the ice thickness and distribution in the Great Lakes, because this is very important for shipping and the economy of the Great Lakes region, to be able to ship products over the Great Lakes year-round. So there are algorithms developed by NASA and by NOAA to figure out how to map the different ice types so that the icebreakers and ships know how to travel safely through the Great Lakes in winter when there's ice there. So that's one of the objectives of the GLAWEX mission. We also want to measure snow water equivalent, as I was mentioning for the Colorado work, in the snow flight line in Michigan. And I won't go into the lake ice work for the small lake because I think I'm running out of time a little bit here. But one of the important features of this GLAWEX work is to validate surface temperatures that are derived from very accurate IR sensors or infrared sensors on aircraft and satellites. So what we're doing is measuring the surface temperature on the ground and comparing that, and even from drones, and comparing that with aircraft and hopefully satellite data if the sky conditions are clear. I'll get into participation in a minute, so I'll skip that for now. These are the flight lines, the current flight lines. First, the plane, when it comes from Colorado, will fly over Green Bay, which is ice-covered part of Lake Michigan. And then it will fly over Lake Michigan. This part of Lake Michigan has no ice in it. Probably won't at the end of the month either. This is the snow flight line right here. Flight line number 4 over in Western Michigan. And then the plane will fly down over Toledo for your test sites there, and then from there back to Maryland. This is the Naval Research Lab P-3 aircraft that will have the sensors on board. There will be a synthetic aperture radar, passive microwave, a multispectral instrument to measure snow albedo. Again, I'm not going to get into the details of this, but let me just suffice it to say that the 2 microwave instruments can see through clouds. So we don't need to worry about clouds for those. But the CAR, which is the instrument to measure albedo, and the thermal infrared suite, the one that we're most concerned about, we have to have clear skies to get accurate thermal infrared temperatures of the ground. This just kind of summarizes what I just said, that we need clear sky view for the infrared data. What kind of measurements are we going to be taking on the ground of the snow? Well, in Colorado, they're going to be doing, well, they have been doing very detailed measurements, including depth, density, water equivalent, et cetera, in snow pits, as well as obtaining meteorological data, surface temperature data, and temperature data from the interior of the snowpack for snow pits, because these measurements affect the microwave and even the infrared signals that we're getting. The infrared signals are only affected by what is on the surface of the snow. So this just summarizes the agencies and universities that are participating in the GLAWEX 17 mission on that day at the end of February. And the schedule, which gets modified every single day. It gets changed. So this is a moving target. We don't know when our flight will be. Right now we're thinking it will be at the very end of February, But I think that's my last slide. So I'd be happy to answer any questions if anybody has any.
Thanks, thanks, Dorothy. And so, yeah, if you have questions, you can enter them into the chat box, or you could unmute yourself, I suppose, and ask them. Try to do one question at a time. And Dorothy, if you wanted to unshare your screen, then we could see.
Did I just unshare it? Did you say?
I need you to click on the red button that says Stop Sharing.
Stop share. Okay. Yes. There.
Really, really good. All right. So, any questions for Dorothy? It could be about this project. It could be about even her career, about NASA. Oops. Yeah, there are questions. Nope, no questions yet. Okay, Eddie McTighe is wondering if the plane could be seen if we are outside.
Could you say that again?
All right. Eddie, a student at McTighe Middle School, is wondering if the plane could be seen if they were outside.
Yes. It will be. Well, it depends on the altitude. We want the plane to fly under the clouds if there are clouds. So you should be able to see the plane. If the plane flies at a low altitude, you'll probably be able to see and hear it. If it's flying at a higher altitude, like 20,000 feet, you might be able to see it, but it'll look like any other airplane up there, and you won't know that it's the plane involved with the instruments in the GLAWEX.
And so Diana John's students at Crestwood High School are wondering if there are any protocols that they can do that are being done in Colorado.
Yes, the surface temperature measurement, particularly if there's snow on the ground. It would be really great for you to measure the temperature of the snow in your little study area. I say little study area because I'm just assuming that you're not going to be traveling along a transect or anything, so it would probably be in one given relatively small area. And if you could characterize that area, in other words, when you're taking that measurement, have a look and say, are there any clouds in the sky? Is this in the middle of a forest, or is it in the middle of a parking lot? Try to be specific on what your study area looks like, maybe take some pictures. So that would be very helpful. And then we can compare the temperature that you're taking with the temperature from the aircraft and satellite if it's clear, and if we're getting satellite data also.
All right. Will we know what time the plane will fly over? That's from Marcy Burns students at Norwalk School.
We will, but we probably won't know that. I mean, I'm sure we won't know that until the day of. We will probably get a pretty good idea of a range of times, certainly the day before and when the plane takes off, but we won't know the exact time until after the plane is in the air, and then it's going to be tricky to be able to get that information and let everybody know. But I'm going to do the best I can to make sure everybody knows everything that I know about it when it's happening.
Right. And so what I'll do is communicate to everybody what Dorothy tells us, and then what we're planning to do here at the University of Toledo is to start taking observations, a few days before, so it's even practice for getting a sense of what the temperature is like, and then when the flight comes over, it will just be second nature. And actually, I have a little PowerPoint to show of what we're planning as far as urban heat island study that we're doing in Toledo. Boy, there's lots of questions coming in. So we don't know the date yet. Peter Dorothy from Rowan University asks when the multispectral data will be available. So we'd like to have access to it.
I heard part of that, and then it got garbled by something.
Okay. Well, we were wondering when the multispectral data will be available.
Oh, okay. It may take a few months to get that data after the overflight.
Okay. So let me share what we're planning to do here for the urban heat island effect. Share my screen. And I started talking about this stuff. Can you see my screen right now?
Kevin, I lost your voice.
Can you see my screen?
Yes. Yes.
Okay. So let's see if I can get this to work.
Okay, now I can hear.
Okay. So I left off here earlier where I was talking about, you can see the urban signature from the cities. Here's Detroit, and then you see Cleveland, Akron, even Buffalo and Toronto on this image, this MODIS image. And I just wanted to focus in on Toronto for a second because they did a really good image. This is an infrared image of Lake Ontario with Toronto to the north. You see the red being the city itself, being much warmer than the area surrounding it. So last night I went on the Weather Underground, and the Weather Underground has their Wonder Maps. It shows air temperature, and hopefully you can see this. The temperatures around the city are in the teens, upper teens, near 20, but in the city itself we have temperature of 28, 29, even 30. Now 30 is near the waterfront, but there's also temperatures of 16 near the waterfront away from the city. So this is showing the urban heat island effect even last night. It's occurring for all our cities on many days of the year. So what we're doing in Toledo, this is a Landsat image showing the land cover in Toledo. We have Lake Erie in blue to the right. We have some clouds, puffy clouds. The Maumee River coming through Toledo. Gray is the city. Green are forest, oak openings forest, and red is agriculture surrounding Toledo. And here's a thermal image from Landsat. And you can see how the downtown area is quite warm. It's red. And you have Monroe Street showing up nicely in red, and then the mall, nice and red. And then the areas around it are more blue. The clouds, of course, are purple. They're very cool. But it's showing the land surface temperature of the city warmer than the surrounding areas. Here's just an example of Ida schools. When our kids go to school, they actually have these settling ponds behind the football stadium. Kind of weird, but anyway, the schools themselves here. And then I overlaid Landsat image just showing like pink is warmer, blue is cooler. So even the school itself is warmer than the areas surrounding it, partly because of the insulation, partly because of the materials, the pavement makes the school warmer than the area around it. So why do we care about the urban heat island effect? Well, one is it increases energy consumption for air conditioning in the summer. Now, of course, in the winter, like here, it actually reduces heating costs, but I think it's offset by the air conditioning worldwide. There's also elevated emissions. For instance, smog, ozone is produced when it's warmer. And lastly, there's quite a number of human health issues. That's why April Ames from the University of Toledo from Public Health is interested in the health impacts of the urban heat island effect, and you actually have increased death rates during heat waves. This diagram shows electric use given the temperature. You notice how electric use is kind of about the same until you hit like 80 degrees, and then electric use goes up quite a bit from air conditioning. And anyway, that's showing how when we have urban heat island, the urban areas warming up, then we are using more electricity for air conditioning. And Dorothy had mentioned about validating satellite imagery, the thermal sensors, and that's one thing that can be done with the surface temperature data that everyone is taking. We have Landsat 8. Actually, Landsat 8 has 2 thermal bands on it. They're having an issue with crosstalk, meaning energy from one band going to another band. MODIS has been taking surface temperature observations since '99, so it's been a very dependable sensor. It's on 2 satellites, Aqua and Terra. And then GOES-16, which was called GOES-R, that was launched in the fall, and GOES-16 also has thermal sensors, a number of bands. So going to our globe observations, so here's a map showing the schools around the world that have taken surface temperature observations. You know, it's a lot in the United States, of course. Let's see, Poland, Croatia, Saudi Arabia, also places, Taiwan, have taken a lot of surface temperature observations. So we're going to use this, the student data as a form of validation for the satellite. You can see here the clustering of schools in the Toledo and Detroit areas, and then over by Cleveland and Akron. Anyway, these are where we're having schools take surface temperature observations. Now, just a reminder, when you take the observations, you want to make sure you hold your hand out about shoulder height, point the instrument down, pull the trigger, let go, then tip it up to read the values. We're looking at kind of 3 p.m. when the plane may fly over, so that may cause problems with schools being over for the day. I know some teachers are talking about students maybe doing an after-school program, that type of thing. And I would like you to take the temperature on grass, a grassy area, and on asphalt to do that comparison. Also, when you take your observations, make sure you do 9, and you do it on a homogeneous area. So here's 9. In the grassy area, notice it's not on the softball field, it's not on this other like playground area, it's in between where the grass is all about the same. So I do the 9 in that area. These are the schools so far I've heard from that are participating, and a number of them are on the call today. Interestingly, we have a drone. Ricky Becker from the Environmental Department at the University of Toledo, he has a drone with a thermal imager on it. And also the Natural Science Technology Center, the Toledo Public School, they have a drone that they are planning to fly as well. So this should give us some interesting data in between the surface observations and the plane and satellites. Now these are some of the things that Dorothy talked about. The flight might be between February 20th and end of the month. I'm guessing later in the month, as Dorothy kind of hinting at, and it could be on Sunday. So something that just to be aware of. Lastly, I want to give a little advertising for the virtual science fair for Globe. If you're doing projects will due April 3rd, and it's a really good opportunity to submit projects online. And then there are regional science fairs. Of course, I forgot the University of Toledo Satellites Conference, which is May 3rd, from 4 to 8 p.m. at the University of Toledo. Then we have the Midwest Regional Science Symposium at Purdue University, May 19th to 20th. Students can present there. On the East Coast, it's actually going to be at the Palmyra Cove Nature Center, where John and Peter are. And lastly, if you have the opportunity, kids can present at the Connecticut annual meeting for Globe. It's going to be in Connecticut this year at the end of July and beginning of August. So I know a number of us are planning to go, and it's a really good time to meet. You can meet students from all over the world and scientists and educators. That's a really neat thing. All right, so I will stop sharing. All right, so going back to questions. Will the plane go over Akron? And will they be collecting data? That's a good question. Dorothy, do you know anything about that?
At this time, the plan is not to fly over Akron, but it's possible that we could change that because we've had to make changes. We were going to fly over Lake Erie, but there was just not enough ice in Lake Erie this year. So we had to change the flight line. So if there's a compelling reason to fly over Akron, we might be able to do that. I could look into that.
Okay, yeah. That'd be great. Another thing, Steve and students in Akron, when we look at satellite imagery, the satellite imagery covers this whole area. So that'll even cover Akron. So that's why I encourage students from Michigan and Ohio to take part in this study, because it's not just the aircraft underneath it that we're hoping to utilize the data, but it's from the whole region. And then when we look at those imagery, for instance, that actually takes imagery of the whole northern hemisphere or western hemisphere, northwestern hemisphere. But anyway, it's a weather satellite that takes imagery, I think, every 15 minutes. So of everybody in the study.
Yeah, that's a good point. If it's clear.
That's right.
And anywhere in the region, the measurements would be really useful for comparison with the satellite data.
Right. And my boy, in the last 2 days, has been very clear. So I've actually been doing aerosol measurements, aerosol optical.
Huh.
So, let's see, another question. Oh, would it be helpful to take surface temperature observations more than once a day, or is it best when the plane is flying over?
If it's a clear day, we'll be getting satellite data. So if you wanted to take surface temperature measurements more than once, then there's a good chance that we would be able to compare that with satellite data. If it's not a clear day, if it's cloudy and the airplane is flying under the clouds, then really the only time that's really important to take the IR surface temperature measurements is during or right before or right after the aircraft overflight. And making a note of the time is very important. Like if you start taking measurements at, I'm gonna make up a time, 2 p.m., and then you continue to take measurements till 3 p.m. Each time you take a measurement, you should record it with the exact time to the minute of the measurement. So that it's useful to have measurements right before, during, and after the aircraft overflight, as long as we know what time those measurements were taken.
Yeah, that's a good point. It may be tough to know exactly when the plane will fly over.
Right.
So,
well, that's why the time is really important, because we will know after it happened. We'll know,
right.
But before we might not know. So if you're not sure when the plane is flying over, particularly if it's flying at 20,000 feet, and you have a lot of measurements from, let's say, 3 to 3:30, we can pin it down after the fact, after the flight. When we get all the data back, we'll know, but we probably won't know that beforehand.
Okay, so we have a question from Diana John's students. What university background is necessary to be a scientist doing research like this?
That's a very interesting question, because there are so many people here at Goddard and at NASA with different backgrounds. Some people have a background in geography, earth science, which is my background. Then there are people with a computer science background. There are people who have a physics background. We have a lot of people with an engineering background. And then now, more recently, we're getting a lot of people with, let's say, forestry or ecology, botany even. And so it really, there are a lot of areas of science that people get into, and then from there go into remote sensing.
Right, and that's a good point, that it takes actually a lot of different types of people to do research, and everybody brings their background and their knowledge to the table.
Right.
Let's see, another question was, if the flight, this is from Marcy Burns, students at Norwalk, if the plane flies over on Sunday, will we need to have extra credit for working on the weekend?
That's probably for one of the teachers to answer.
That's a good one.
I'll give you extra credit.
That's right, yes. Credit from NASA. And John Moore asks, and this is from the Palmyra Cove Nature Center, is there a plan to make a ice and snow product for GOES 16?
Kevin, the question, I heard it, and then all of a sudden, everything froze, and then you came back. So if you could repeat that question.
Sure. Yeah, are you planning to develop a snow and ice product for GOES 16?
I am not. I do think there are plans to develop a snow and ice product, or at least a snow product for GOES 16, but I'm not personally.
Okay. And then Steve Francis students want to know if they should submit their data to the GLOBE website, and the answer is yes. So all students, please submit your data to the GLOBE website, because that's how we're going to collect the data, and the data can be shared with everyone. Now, I guess I'll say an interested student could use this data for their GLOBE project or their project for a science fair. There's going to be quite a number of schools taking observations during this week, during this field campaign, basically from February 20th and hopefully through the end of February to catch this this overflight. And just to say, how unusual it is for a NASA plane to fly over.
Learn to understand you much better if I can get familiar with the way you talk.
I'm not sure what that.
I need your permission to help.
I'm not sure what that is. Sorry.
Yeah, that's okay. So, well, anyway, I'm getting older, and NASA's never flown a plane over my site before where I've been. Usually I've gone to Canada or somewhere where NASA has a field experience. So this is somewhat of a lifetime opportunity. NASA flying a plane over. Dorothy, she was kind enough to contact me saying, hey, we're flying over near in Toledo. Can we involve the students in a project? I said, yeah, let's do it. So that's how this all came about. It was all Dorothy's idea. And I was very happy to get you involved, and I see your teachers getting you involved as well. Any other last questions before we turn off?
Well, I do want to just comment on that, Kevin. I gave a presentation recently to NASA headquarters, and they had no idea that this educational component was involved until I told them. And the two headquarters managers were very, very happy about this. The fact that you're involved, and all these students and teachers are involved, and they want to make a big deal out of it. So I'll probably be contacting you by email and asking you to make it like a little paragraph write-up that I can send to them, because it is something that NASA is very happy about, this outreach, and especially the education and outreach. So I want to thank you and everybody for being involved in this. And with these field experiments and aircraft experiments, you never know, but we hope it'll all work out well. But it's always a risk. Weather and other problems always crop up, but we're excited about it.
Well, thanks, Dorothy. And every time there's a Great Lakes ice study, that's the year that it's very low ice cover.
I know.
So I know many years ago, one of the scientists from NOAA, the Great Lakes Environmental Research Lab, they had to do their studies up in Lake Superior because it was even less ice than this year. But this is the ice cover from yesterday. So looks like there's about 10% of the Great Lakes covered with ice, which is very, very low for this time of year.
Yeah, that's very disappointing.
Always works that way.
Yeah, it does.
So now this is the big question. Maybe we'll end with this. Is Diana John's students want to know, is this project related to any other environmental remote sensing that NASA is doing?
Yes, very much so. It's related to the MODIS project. It's related to the VEERS project. I mean, it's a big acronym, so I won't say it, but it is related to a lot of other NASA and NOAA work that's ongoing right now. So it's actually very important. And this experiment involves in Colorado people from all over the world. And for the Michigan component and the Ohio component, you saw the number of universities that are involved in the US, and that also includes one in Canada. So the whole SnowEx project for this year is quite a big deal, and it's actually a 5-year program, and we're just in the first year of it. So there may be possibilities for doing more of this same kind of work in future years.
Great. All right, well, thanks, Dorothy, and thanks everybody for calling in.
Okay, well, thank you, Kevin. I've just lost you.
Okay, well,
You just froze, but anyway, thank you.
all right, thanks, Dorothy.
Thanks, bye.
Everybody,
Bye.
nice leaving.
All right, thanks.
Oh, and Debbie Millay at Wait High School, hi. You are on.
Dorothy, you still there?
Yes, should I be getting off now?
No, Dorothy, it's Peter from the Palmyra Cove and Rowan University. I just wanted to mention it was great meeting the famous Dorothy Hall.
Oh.
I'm doing some research at the university on lake ice detection of the Great Lakes right now. I just had my first paper published with Jeff Key and Peter Romanoff.
Oh, great.
I'd love to pick your brain on some ideas that I've been working with on GOES 13 that I then like to carry over to GOES 16. But this is a wonderful project, and I'm also as a global scientist, I'm also getting students involved in the research as well. But anyway, I'd love to pick your brain some more.
Oh, great. Just send me an email and we'll figure out when we can do that.
Great, thanks, Dorothy.
Okay, thank you.
I'll be sending emails. Everybody, to let me know what's going on.
Okay,
Take care.
thank you.